Alright, so in this video we're going to talk about writing out double and triple bonds in Lewis-Dot structures. So if you remember, a covalent compound has shared pairs of electrons, and a single bond is a one shared pair of electrons between two atoms. But sometimes in order for molecules or the atoms and molecules to satisfy the octet rule, they have to share more than one shared pair of electrons, sometimes two, sometimes three pairs, and that leads to double or triple bonds. First example, probably easiest one we'll start with, is oxygen, O2. Now, if we do the Lewis-Dot structure for an oxygen atom, there you go, there's its 6 valence electrons. And I'll do another oxygen atom with its 6 valence electrons. All right. Now remember that these lone electrons there, they're looking to pair up with another electron. And they'll typically look for lone electrons on another atom. So you can probably figure out by now, you can see this electron will want to hook up with that one. That one will want to hook up with that one. So if we put together, it'll look something like this. There's our one oxygen here. There's our other oxygen here with their unshared electrons. And then these here will pair up in the middle. There's one shared pair, and there's two shared pairs. All right. So there's your two shared pairs of electrons, otherwise known as your double bond. And we can rewrite this as oxygen and our other oxygen. Instead of the two pairs of dots, we'll do two lines. And there we go. There's the Lewis-Dot structure for oxygen, O2. Now we can also do nitrogen, N2. Remember, the nitrogen atom has 5 valence electrons. So if we write this out, there's nitrogen with 5. There's another nitrogen with 5. All right, so why don't you pause and figure out how this will work. All right, so let's try this. So we got this one, and this one. There you go, they'll find their partners there. So we can rewrite this as nitrogen, and we got these two here, and they can go top, bottom, right, doesn't matter. Here's your other nitrogen. The two lone electrons there, put those there. And then 1, 2, and 3, 1, 2, and 3, 1 pair, 2 pair, 3 pair. And you got that. So nitrogen has a triple bond. And for both of these, still satisfy our rules about the octet rule and the total number of electrons. All right, if you look back at oxygen, each has 6 valence electrons. That's a total of 12. 2, 4, 6, 8, 10, 12. And each oxygen has 8, right? 1, 2, 3, 4, 5, 6, 7, 8 for that oxygen. 2, 4, 6, 8 for that one. Nitrogen, 5 electrons each for a total of 10. So this nitrogen, you count those two, plus 2, 4, and 6. That's a total of 8. This nitrogen, 2 there, 4, 6, 8. So that nitrogen has 8. 2, 4, 6, 8, 10 total electrons. Just like we're supposed to have. Perfect, right? All right, one more we'll do. Will be carbon dioxide, CO2. So we're going to give this a shot. So why don't you press pause and try it on your own. All right, we're back. So carbon, 4 electrons. Oxygen has 6. So there's 1 oxygen, so you can probably figure out the other one. So that one pairs that. That won't pair up with that. So put our other oxygen here. There's 6 electrons for oxygen. Boom and boom. All right, looks like we got a couple double bonds here, right? That's the right side. On the left side looks the same. There you go. So that's how you do double and triple bonds. All right, if you need to, look for bonding sites that need to pair up. And if you have multiple bonding sites that can pair up in between 2 atoms, then that's where you get your double and triple bonds.